Good afternoon, everyone. I'm really pleased to be here today to give you a kind of a brief overview of what we're doing with our phase one rollout of Smart Grid. So you might ask, well, why is OPPD doing this? Why are we doing the Smart Grid? Well, one of the reasons is so we can gain experience integrating smart devices on the OPPD system. You might have heard a term like Internet of Things, and this is along those lines. The deeper goal is to be able to get in and turn this data that we get from the system into usable information for our operations to provide service to our customer owners. The second is a chance to evaluate in the real world the performance of communication technologies. Various pieces of this project will use both OPPD-owned private radio system as well as a private network over a public carrier, which is cellular. So we're using both technologies. Both are certainly proven and secure within the industry, but this gives us a chance to test them on the OPPD geography and topology and see how they perform for us on our system. And then finally, to prepare for the future. While no one has a crystal ball to know exactly what the future holds, we know that things are going to continue to change as technologies evolve, as the costs associated with those technologies evolve. The way that we deliver energy may change. We may have a little bit more of a two-way system where we have not only consumers but prosumers who may produce some energy as well as consume. So this helps us get on that path. Some of the detailed project objectives include increasing the grid and customer reliability for this area. With the information that we'll be receiving from the devices, we're able to better analyze outages and respond to them quicker, having a better idea of what the problem may be ahead of time. And by doing that, we hope to realize some O&M savings from our operations. Another aspect of the project is to be able to shave a little bit of our peak demand through what's called volt-var optimization, and I'll talk a little bit more about that as we go through the presentation. And also increasing the real-time system monitoring out on our distribution system, putting those eyes out there electronically to see what's going on. And then finally, the last piece of the project is we're also including a few AMI meters as kind of a test and a proof of concept of that technology. If you take a look at the project area, it's roughly from about 30th Street to 52nd, and then from Maple up to Ida is kind of our 4 square mile area where the project is taking place. We've got 5 of our distribution circuits in the area from 2 substations, just under 10,000 customers in there with a little bit of a mix between our customer classes. And also as part of our project, we did a communication where a letter was sent to the homeowners in this area letting them know that we're going to be doing some work in their area to upgrade the system and that they were going to be a part of this project. So if we take a look at what does this technology kind of look like, the big piece is the communication network that we're overlaying on our traditional grid. And that communication will allow us to get real-time information from our recloser devices, capacitors, and faulted circuit indicators, all of which we use on our system today and have for many years. What's new is being able to have the communication piece to get back data from those real time, and we'll talk a little bit more about those, and as well as the automation controller that kind of puts the system together. So we'll talk a little bit about how it works. The idea is to break the system up into 2 or 3 segments by adding the reclosers, and so that reduces the number of customers affected. One example that you might think of, like in your house, is your refrigerator is not on the same circuit as your counter appliances or your dishwasher or your oven. So if you're going to have a big holiday party and you plug in one too many crock pots, you don't lose your refrigerator at the same time. So it's a similar concept here where we're reducing it and breaking it up. And then what's really new and really exciting about this project is we're able to automatically restore to the unfaulted segment. So if, say, a circuit's broken into 3, we have a fault on one segment, the 2 segments where we don't have an issue, we don't have any problem, there's nothing broken, the tree on the line, we're able to restore that very quickly within a matter of minutes. Second is the pieces are capacitors, where we're going to do a remote centralized control of them. And what this does is can help reduce our system losses and reduce our peak demand depending on how we choose and to operate those. Without getting too deep into the electrical engineering, really what these devices do is help with the efficiency of the system, help help reduce some of those losses in real time. And like I say, these are devices we've used on the system for many years, but more of in a autonomous mode where when the weather comes on, at 90 degrees, we may have one turn on to help system voltage, and then as the temperature drops back to 80, it turns off, which generally follows our load pretty good. But now we'll be able to maximize that kind of every few minutes, minute to minute throughout the day to really get that full benefit. Also, we'll be using communicating faulted circuit indicators. These are devices that clip on to the overhead lines, the conductors, and what they'll do is, as if those see the fault current, if the problem is on downstream, those will flash so the crews in the field can see those. But with these new devices, they'll also send a signal back electronically, and we'll see that in the control center as well. So we'll really have an idea before we even send a crew of what the problem may be. And then finally, we're using devices called the RTAC, or the Real-Time Automation Controller, which is really the brains of this smart grid system that allows us to bring all that information back and then be able to make decisions and operate with it. So I'll talk a little bit about our progress to date. We do have the faulted circuit indicators installed, and they are communicating back to our control center. The capacitor control commissioning and testing is in progress as we speak. Our recloser installation's in progress, and we'll be commissioning those early next year in January. And then the final kind of piece is the operator and field crew training on these new devices, and we expect that to be on first quarter so that we can be ready to go before the spring storm season that's typical in Nebraska. So if we talk about what's next, what are our next steps, what we're going to do is track the results that we see from this. We want to track the reliability improvement. We want to understand and capture the cost savings. We want to understand what our demand reduction is to be able to integrate those into our future plans and beyond. So this is our phase one. As we move, the next steps may look a little different, kind of depending on what we decide to do. It's kind of like if you when you go to purchase a car, you say, okay, I want the heated seats and the Bluetooth and the moonroof, and then as you go, you say, oh boy, the Bluetooth and the heated seats are great. I can't live without them in the Nebraska winters. But the moonroof, I used it a couple times. Maybe it's not as value. But then in Nebraska winter, I wish I would have done like a 4-wheel drive. So I want to add that piece. So like I say, as we go and evolve and track what we're doing, it will evolve and look a little bit different. But this is really our first step into this to really help our operations and really, like I say, turn that data into useful information.